It is concerning to hear about such a conflict of interest within the electrical industry. Here are some points to consider. Firstly, ethical concerns. The electrical inspector has a duty to ensure the safety and code compliance of electrical installations. By offering to waive inspection fees for customers who choose their contracting services, they are potentially compromising their impartiality. Secondly, competitive advantage. This practice gives the inspector an unfair advantage over other contractors. Customers may be more inclined to choose the contractor who is also the inspector, even if they offer a higher price or lower quality services. Thirdly, public trust. The public relies on electrical inspectors to ensure the safety of their homes and businesses. When an inspector has a financial incentive to pass an inspection, it can erode trust in the inspection process. Fourthly, legal implications. In some jurisdictions, such practices may be considered illegal or unethical. It is important to verify local laws and regulations. Other contractors may have mixed feelings about this situation. Some may feel that it is unfair competition, while others may question the integrity of the inspector. It is also possible that some customers may appreciate the convenience of having the inspection included in a contract price. While one cannot prevent the inspector from using their title in their sales pitch, here is what one can do. Firstly, educate customers. Inform customers about the potential conflict of interest and encourage them to seek multiple bids. Secondly, highlight qualifications. Emphasize experience, certifications, and adherence to industry standards. Thirdly, offer value. Provide excellent customer service, competitive pricing, and high-quality workmanship to differentiate oneself from the competition. Fourthly, report concerns. If one believes that the inspector's actions violate any ethical or legal guidelines, one can report concerns to the appropriate authority. It is important to remember that customers ultimately make their own decisions. By providing transparent information and showcasing professionalism, one can compete fairly and maintain a positive reputation in the industry. The role of an electrical inspector is to ensure the safety and compliance of electrical installations with established codes and standards. This is a crucial function, as faulty or non-compliant electrical work can lead to serious hazards, including fires, electric shocks, and equipment damage. When an electrical inspector also operates as an electrical contractor, a conflict of interest arises. The primary duty of an inspector is to impartially assess electrical work and identify any deficiencies or violations. However, if the same individual is also a contractor, they may be tempted to overlook issues in their own work or the work of their company to avoid incurring additional costs or delays. This can compromise the integrity of the inspection process and potentially put the safety of the public at risk. An electrical inspector should possess a thorough understanding of the National Electrical Code, or NEC, as well as any local amendments or regulations. They should be able to interpret and apply these codes accurately and consistently, ensuring that electrical installations meet the minimum safety requirements. Inspectors should also be knowledgeable about different types of electrical systems, equipment, and materials, and be able to identify potential hazards or defects. To maintain impartiality, electrical inspectors should avoid any financial or personal relationships that could compromise their judgment. This includes not accepting gifts, favors, or bribes from contractors or property owners. Inspectors should also recuse themselves from inspecting any work that they or their company have performed. The conflict of interest that arises when an electrical inspector also works as a contractor can create an unfair competitive advantage. The inspector may be able to offer lower prices or faster service because they can waive inspection fees or expedite the inspection process for their own customers. This can make it difficult for other contractors to compete, even if they offer higher quality work or better customer service. The public relies on electrical inspectors to protect them from the dangers of faulty electrical work. When an inspector has a financial incentive to pass an inspection, it can erode trust in the inspection process and undermine the public's confidence in the safety of electrical installations. In many jurisdictions, there are laws and regulations in place to prevent conflicts of interest in the electrical industry. These laws may prohibit electrical inspectors from also working as contractors, or they may require inspectors to disclose any potential conflicts of interest. It is important for contractors and property owners to be aware of these laws and regulations and to report any suspected violations to the appropriate authorities. When faced with a situation where an electrical inspector is also a contractor, there are several steps one can take to protect their interests. Firstly, obtain multiple bids from different contractors. This will allow them to compare prices and services and to choose the contractor that best meets their needs. Secondly, check the contractor's qualifications and experience. Make sure that the contractor is licensed and insured and that they have a good reputation in the community. Thirdly, ask the contractor about their relationship with the electrical inspector. If the contractor is also the inspector, be sure to inquire about how they will ensure impartiality in the inspection process. Fourthly, consider hiring an independent electrical inspector. This will ensure that the inspection is conducted by a qualified and impartial professional. Fifthly, report any suspected violations of ethical or legal guidelines to the appropriate authorities. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and to address emerging safety concerns. Electrical inspectors use the NEC as a guide when inspecting electrical installations to ensure that they meet the minimum safety requirements. Some key areas covered by the NEC include grounding and bonding, overcurrent protection, wiring methods, and equipment installation. Grounding and bonding are essential for preventing electrical shock hazards. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices will trip or blow when the current exceeds a certain level, preventing damage to equipment and reducing the risk of fire. Wiring methods refer to the types of wiring and cables that are used in electrical installations. The NEC specifies the types of wiring that are permitted for different applications, as well as the methods for installing and supporting the wiring. Equipment installation requirements cover the proper installation and use of electrical equipment such as lighting fixtures, appliances, and machinery. The NEC provides detailed instructions for installing and connecting this equipment to ensure that it operates safely and efficiently. In addition to the NEC, there may be local amendments or regulations that apply to electrical installations in a particular jurisdiction. These local requirements may be more stringent than the NEC in some cases, and electrical inspectors must be familiar with both the NEC and the local requirements. To become a qualified electrical inspector, individuals typically need to complete a combination of education, training, and experience. Many inspectors have a background in electrical construction or engineering. They may have completed an apprenticeship program, earned a degree in electrical engineering, or have several years of experience working as an electrician. In addition to formal education and training, electrical inspectors must also pass a certification exam. There are several different organizations that offer electrical inspector certifications, such as the International Association of Electrical Inspectors, or IE, and the National Fire Protection Association, or NFPA. Continuing education is essential for electrical inspectors to stay up to date on the latest changes to the NEC and other relevant codes and standards. Inspectors may attend workshops, seminars, or online courses to maintain their certification and to enhance their knowledge and skills. The role of an electrical inspector is critical for ensuring the safety of electrical installations and protecting the public from electrical hazards. When an electrical inspector also operates as an electrical contractor, a conflict of interest arises that can compromise the integrity of the inspection process. It is important for contractors, property owners, and the public to be aware of this potential conflict of interest and to take steps to protect their interests. Some states have regulations that address conflicts of interest for electrical inspectors. For instance, some states may prohibit an electrical inspector from performing inspections on properties where they have also performed electrical work within a certain time frame, such as 1 year. These regulations aim to maintain impartiality and prevent inspectors from favoring their own work. Additionally, many municipalities require electrical contractors to obtain permits before starting any electrical work. This process helps to ensure that the work is inspected by a qualified inspector and meets the required safety standards. The permit application typically includes detailed information about the scope of work, materials to be used, and the contractor's qualifications. When an electrical inspector is also a contractor, it can be challenging to maintain objectivity during inspections. They may be tempted to overlook minor code violations or use low-quality materials to save costs, especially if they are inspecting their own work. This can compromise the safety of the electrical system and potentially lead to future problems. To mitigate these risks, it is crucial to have clear separation of duties and responsibilities. Ideally, electrical inspections should be performed by independent third-party inspectors who have no financial interest in the outcome of the inspection. This ensures that the inspection is conducted fairly and impartially. In addition to ethical considerations, there may also be legal implications for electrical inspectors who engage in conflicts of interest. Depending on the jurisdiction, they could face disciplinary action, fines, or even criminal charges. It is important for inspectors to be aware of the relevant laws and regulations and to adhere to the highest ethical standards. When choosing an electrical contractor, it is always a good idea to get multiple bids from different contractors. This allows you to compare prices, qualifications, and experience. It is also important to check the contractor's references and to make sure they are licensed and insured. If you have any concerns about a contractor's relationship with the electrical inspector, you should raise those concerns with the appropriate authorities. Electrical safety is paramount, and it is essential to ensure that all electrical work is performed by qualified professionals and inspected by impartial inspectors. By promoting transparency and accountability, we can help to protect the public from the dangers of faulty electrical installations. The typical voltage supplied to residential homes is 120 volts for lighting and small appliances, and 240 volts for large appliances such as electric stoves, dryers, and air conditioners. Commercial buildings may have 208 volts, 277 volts, or 480 volts depending on the size and type of electrical equipment they use. The current carrying capacity of electrical wires is determined by their size and insulation type. The National Electrical Code, or NEC, provides tables that specify the allowable ampacity of different types of wires under various conditions. For example, a 12 American wire gauge, or AUG, copper wire with THHN insulation has an ampacity of 20 amps when installed in a conduit. It is important to choose the correct wire size for the load to prevent overheating and potential fire hazards. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. They work by monitoring the current flowing in the hot and neutral wires of a circuit. If there is a difference of more than 5 mA, the GFCI will trip, interrupting the circuit and preventing a shock. GFCIs are required in bathrooms, kitchens, and other wet locations. Arc fault circuit interrupters, or RFCIs, are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat and potentially igniting nearby materials. RFCIs can detect these arcing faults and trip the circuit, preventing a fire. RFCIs are required in bedrooms and other areas where people sleep. Surge protectors are designed to protect electronic equipment from voltage spikes. Voltage spikes can damage sensitive electronic components and cause equipment failure. Surge protectors work by diverting excess voltage to ground, protecting the equipment from damage. It is important to use surge protectors for computers, televisions, and other valuable electronic devices. Electrical panels should be properly labeled to identify the circuits they control. This makes it easier to troubleshoot electrical problems and to turn off the correct circuit when performing electrical work. The labels should be clear and accurate, and they should be updated whenever changes are made to the electrical system. Electrical work should always be performed by qualified professionals. Electricians have the training and experience to safely install and repair electrical systems. They are also familiar with the National Electrical Code, or NEC, and other relevant codes and standards. Attempting to perform electrical work without the proper knowledge and skills can be dangerous and can lead to serious injury or property damage. Regular electrical inspections can help to identify potential problems before they become serious. Electrical inspections should be performed by qualified inspectors who are familiar with the National Electrical Code, or NEC, and other relevant codes and standards. The inspector will check the electrical system for safety hazards and code violations, and they will provide a report outlining any necessary repairs or upgrades. The color coding of electrical wires is standardized to make it easier to identify the different conductors. Black wires are typically used for hot wires, white wires are used for neutral wires, and green or bare copper wires are used for ground wires. This color coding helps to prevent accidental shocks and other electrical hazards. When working with electricity, it is important to follow all safety precautions. Always turn off the power before performing any electrical work. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses. Never work on electrical equipment in wet conditions. If you are not comfortable working with electricity, call a qualified electrician. Electrical safety is everyone's responsibility. By following these safety tips, you can help to prevent electrical accidents and injuries. The use of proper personal protective equipment, or PPE, is crucial when working with electricity. This includes insulated gloves, safety glasses, and appropriate clothing. Insulated gloves protect against electrical shock, while safety glasses protect the eyes from flying debris. Clothing should be made of non-conductive materials and should fit properly to avoid getting caught in machinery. Before starting any electrical work, it is important to identify all potential hazards and take steps to mitigate them. This includes identifying live electrical circuits, exposed wiring, and damaged equipment. Once the hazards have been identified, take steps to eliminate or control them. This may involve energizing circuits, isolating equipment, or providing additional guarding. Lockout-tagout procedures are used to ensure that electrical equipment is de-energized before maintenance or repair work is performed. Lockout involves physically disconnecting the equipment from its power source and applying a lock to prevent it from being re-energized. Tagout involves attaching a tag to the equipment to warn others that it is de-energized and should not be operated. These procedures help to prevent accidental energization and potential injury. Electrical safety training is essential for anyone who works with electricity. Training should cover topics such as electrical hazards, safety procedures, personal protective equipment, and lockout-tagout procedures. Training should be provided by qualified instructors and should be updated regularly to reflect changes in codes and standards. Regular inspections of electrical equipment can help to identify potential problems before they become serious. Inspections should be performed by qualified personnel and should cover topics such as wiring, insulation, grounding, and overcurrent protection. Any defects or deficiencies should be corrected promptly to prevent accidents and injuries. Electrical safety audits can help to identify areas where electrical safety practices can be improved. Audits should be conducted by qualified auditors and should cover all aspects of electrical safety, from training to equipment maintenance. The results of the audit should be used to develop an action plan to address any identified deficiencies. Electrical safety committees can help to promote electrical safety within an organization. The committee should include representatives from all departments and should be responsible for developing and implementing electrical safety policies and procedures. The committee should also be responsible for providing training and promoting awareness of electrical safety issues. Electrical safety should be a top priority for everyone. By following these safety tips, you can help to prevent electrical accidents and injuries. The resistance of a conductor is measured in ohms. The resistance depends on the material, length, and cross-sectional area of the conductor. The longer and thinner the conductor, the higher the resistance. The resistivity of a material is a measure of its ability to conduct electricity. Materials with low resistivity, such as copper and aluminum, are good conductors of electricity. Materials with high resistivity, such as rubber and glass, are good insulators. Ohm's law states that the voltage across a conductor is equal to the current flowing through the conductor multiplied by its resistance. This law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. Power is the rate at which electrical energy is transferred. It is measured in watts. The power consumed by a device is equal to the voltage across the device multiplied by the current flowing through the device. Electrical energy is measured in kilowatt-hours. 1 kilowatt-hour is the amount of energy consumed by a 1000-watt device operating for 1 hour. Electrical energy is typically billed to consumers in kilowatt-hours. Transformers are used to step up or step down voltages. A step-up transformer increases the voltage, while a step-down transformer decreases the voltage. Transformers work by using the principle of electromagnetic induction. Capacitors store electrical energy in an electric field. The capacitance of a capacitor is a measure of its ability to store electrical energy. Capacitors are used in a variety of applications, such as filtering, energy storage, and timing circuits. Inductors store electrical energy in a magnetic field. The inductance of an inductor is a measure of its ability to store electrical energy. Inductors are used in a variety of applications, such as filtering, energy storage, and oscillators. Diodes are semiconductor devices that allow current to flow in only one direction. Diodes are used in a variety of applications, such as rectifiers, switches, and voltage regulators. Transistors are semiconductor devices that can be used to amplify or switch electronic signals. Transistors are used in a variety of applications, such as amplifiers, oscillators, and digital circuits. Integrated circuits, or ICs, are complex electronic circuits that are fabricated on a single semiconductor chip. IC are used in a wide variety of applications, such as computers, cell phones, and appliances. The NEC Table 310.15 provides guidance on the allowable ampacities of conductors. It is essential to consult this table when determining the appropriate wire size for a given application. NEC Section 250.118 covers the types of equipment grounding conductors. It is essential to understand these requirements to ensure proper grounding of electrical equipment. NEC Section 300.11 covers securing and supporting wiring. This section provides guidance on how to properly secure and support electrical wiring to prevent damage and ensure safety. NEC Section 408.3 covers the identification of circuit breakers. It is essential to properly identify circuit breakers to ensure that they can be easily located and operated in an emergency. NEC Section 517.13 covers the wiring and grounding requirements for healthcare facilities. These requirements are more stringent than those for other types of facilities due to the increased risk of electrical shock to patients. NEC Section 690.47 covers the grounding requirements for solar photovoltaic systems. These requirements are essential to ensure the safe operation of these systems. The authority having jurisdiction, or OJ, is the organization that is responsible for enforcing the electrical code. The AHA may be a local, state, or federal agency. It is essential to comply with the requirements of the AHA to ensure the safety of electrical installations. Electrical safety is a shared responsibility. Everyone, from homeowners to electricians, has a role to play in preventing electrical accidents and injuries. By following safe electrical practices and complying with the electrical code, we can create a safer environment for ourselves and our communities.